The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon and welcome, everyone. My name is Eva Dace, and I am a member of the marketing department here at Vitech Corporation. I will be your host during today's webinar as we proudly introduce GENESYS 2.0. Before we get started, I would like to review a few technical details. First, questions. Please feel free to submit your questions anytime via the Q&A function in the GoToWebinar window. We will be monitoring these throughout today's event. We plan to respond to the questions at the end of the webinar, so stay tuned. Second, recording. The webinar is being recorded today. If you are having technical difficulties during the presentation, an online archive with this presentation will be available within 24 hours of the live presentation. I believe that takes care of all our housekeeping matters, so let's get started. Let me introduce you to our two presenters today. Jim Obermayer is Vitech's Vice President of Business Development. Jim came to Vitech from a private consulting company, Sales Leakage Consulting, and is also a co-founder of the Sales Lead Management Association, currently serving over 6,300 members. Also presenting today is Warren Smith, an accomplished systems engineer and one of our senior account executives. Warren has 25 years of experience in systems engineering, working as a program manager, field engineer, and entrepreneur. And now, the moment we have all been waiting for. Welcome Jim Obermayer and Warren Smith and GENESYS 2.0.
Thank you, Eva. It's great to be here today. The title of our presentation is Genesis, Where Insight Begins. I am Jim Obermayer, your panelist today, working with Warren Smith, our systems engineer, and one of our senior account executives. Warren, are you there?
I am. How are you doing, Jim?
This is a great day to introduce Genesis 2.0. I think people are going to be excited about what they hear today.
Yeah, I think so too, Jim. Let me dive into a little bit about what Genesis is, and then we can get into a demo. How's that sound?
Sounds great. Let's get launched.
Okay. Well, Genesis is a model-based systems engineering tool that enables large systems development teams to build complex systems in a collaborative environment. It supports different types of users, systems engineers, mechanical or software engineers, program managers, and so forth, and also that constellation of people on the team that just need to review and comment. They can all work together in the Genesis environment. So Genesis is actually an evolution of Vitech's tool core, which many in our audience, I suspect, are familiar with. Genesis is it's a model-based systems engineering tool that manages system requirements and designs and tests. It builds on many of Core's features and runs on a Windows 7 .NET framework. It uses Visual Basic as its scripting language. It uses a SQL Server as a repository, and it comes in a couple of different flavors. A fantastic new option that I like is Genesis Collaborative Edition. This edition lets up to 5 Genesis users share a repository without having to buy a separate Genesis server. So now small teams can benefit from MBSE at really a much lower cost point. So that's kind of an intro to Genesis. Genesis open architecture, and its Visual Basic API means that your ability to integrate your MBSE tool with other tools on your campus is now wide open. The API provides full read-write access to the repository. Integrating Genesis MBSE to CAD is no problem. SharePoint, if you have finite element modeling tools, or even Office products, it can all be done in a snap. So, Jim.
Well, what we're talking about today is Genesis 2.0, but tell me, Warren, is this replacing Core?
No, it's not replacing Core yet. Genesis 2.0 is approaching that level of maturity that our customers really demand, but I don't really expect it to fully supplant Core until version 3.0. But you'll see during the demo here in a minute that Genesis is really growing up. You'll see some familiar capabilities that have been turbocharged with some really cool new features like the drag and drop report designer. Genesis comes out of the box with document generation and DODEF views and SysML and system specs and that kind of thing, but the new report designer, that allows engineers and managers to really quickly build custom reports without scripting, Jim.
Well, Genesis certainly has features that really reduce cost and increase quality. I like to know, I'd like to see how it reduces costs by eliminating the drudgery of documentation. That's the number one thing I've been hearing on a lot of trips lately, and even at some of the INCOSE meetings. Its ability to present the design in formats most familiar to each team member is a boon to the collaboration and the communication of most systems engineering teams. And I think you're going to show how Genesys MBSE model, how that model can replace real prototypes and virtual prototypes, aren't you?
Yep. Mm-hmm.
Now, what tremendous savings in time and money this program is going to provide the systems engineering community.
Boy, that's for sure. Shall we go ahead and take a look?
By all means, let's go.
Okay, let me bring this up. Okay, can everyone see my copy of Genesys Spectrum? Can you see it, Jim?
Yep, I can see it.
Okay. All right, good. I'm going to go ahead and get started. Some of this you'll see if you're used to Vitech's tools in the past. Some of this will look familiar. This is just the launch pane where we will open up our new project. But if you look up here, we also have the more modern features that one expects in today's development platforms. So we have a ribbon up here. It's context sensitive. I talked already about the SQL Server underneath and so forth. To get started with new project, we're going to click on a new project and we're going to create a new flex fuel vehicle design. So it's going to be like a car, perhaps, and it would run on both gasoline and natural gas. And today, as just kind of an overview, I'm going to walk you through what it looks like to create a project, and then in a few minutes we'll start populating that project. So I mentioned the context-sensitive ribbon at the top. On the left side, we have a Project Explorer. And the Project Explorer provides, as you would expect, the folders containing the different types of elements in systems engineering. So we have architecture captured in the component folder. We have behavior captured in the functions folder. We have requirements down here. And if I scroll down, we even have quite a few elements for test activity and states and modes and use cases and so forth. Now, one can create any new elements inside this. We're going to design a 2015 model year. It's called the Flex Fuel vehicle. So I'm just going to type that in here, and I'll correct that spelling there. And when I create an element, so this would represent the top level of our system. So everything that goes into the system will become children of this. But by clicking on this, you can see that this browser pane here lists all the elements that are in any of these folders. So this folder has turned a color indicating that it is no longer empty like the rest. And this is the one element that's in there. Now, we can apply a lot of different types of attributes to this. Let me scroll to the top of this attribute pane. We call this the property sheet, and you can assign different numbers to this. You can put a description in here of what the system is. You also can capture things like cost bogeys that you may want to meet. We have a document unique PUID. We call it a program unique identifier. In fact, there's an awesome PUID wizard here that you can go through and auto-generate PUIDs for all elements in your system. These are the unique unchanging numbers that represent system elements. There's other attributes. You can show, for instance, what type of component this is. Is it a hardware or software or system component, or even a system of system? You can identify, I mentioned cost bogeys, budgeted costs and so forth, purposes, missions, and just all sorts of different types of information. One of the things that's really nice about Genesys is that these attribute values along the side, if you like the property sheet database view, you can add new ones just by switching into the schema and adding them. If you have drop-down values that you want to see that aren't listed here, then you can add them to your list here as well. The last element of the pane here, the the palette, if you will, is the list of relationships that this component can have. This component, for instance, if I drop down here, it can be specified by requirements. It can be decomposed into other components. It can perform functions. And I'm going to show Jim, everyone, how we do this in a few minutes. The last piece is there's a graphical nature associated with Genesys. So here, if I click on the component hierarchy, we have, of course, only one component right now, the top-level system component, but you can see that that's visible graphically as well. So, Jim, Genesys is a true model-based systems engineering tool.
Well, model-based systems engineering, or MBSE, is definitely on everybody's minds right now. When I go to the NCOSE meetings here, you know, I'm on the West Coast. We've got a big chapter out here in Los Angeles, and it's a big topic out here, even down in Houston and going down there. I talk to a lot of people who've heard of MBSE, and we get out to a lot of the commercial sites too, but sometimes they aren't clear on what it is. They have systems engineers, but they're not quite clear about what MBSE is. Maybe we should explain it for our listeners.
Yeah, I think that's a good idea. There's definitely a lot of confusion in the people I talk with as well as to what the key aspects are of MBSE. So MBSE has several key aspects. It's model-centric, not diagram-centric. It supports the auto-generation of views. There's unambiguous notation and defect identification early in analysis, and there's virtual prototyping. We're going to talk about many of these today. The first characteristic of MBSE is that it is model-centric. If you're going to have model-based systems engineering, it should be model-centric, not diagrammatic or diagram-centric. And this manifests itself in several different ways. First, models can be built up layer by layer and can actually be populated from a reuse library. So let me go ahead and show you how that works. I've got this empty project here with the Flex Fuel vehicle. I'm going to go ahead and show how we would build up a library from a reusable library of components from the Genesys library. So, for instance, we've designed engines before for our mythical automobile company here. So we have different types of engine designs which we've used, designed in Genesys or even in Core previously. We have a diesel, a flex fuel, we have a gasoline engine, and a hybrid electric gas hybrid engine as well. All of these are complete models. They have requirements, they have interfaces, they have behavior and architecture, and we can use any of these and reuse them in our new design. In the driver station, we have a basic driver station. That's the driver's controls, steering wheel and dashboard, that kind of thing. It's called driver station. And we also have one that we've designed for our handicapped customers with all the controls at the steering column. We have different types of suspensions and so forth. Now we're going to actually go through and import these. What I would be doing here is selecting each of these. I'm going to import the driver station and the flex fuel engine, and I would go through and do that. It takes about 3 minutes per model to import, Jim. So what I'm going to do here is to cancel out of this. I've previously imported them to save us those 6 precious minutes in our webinar here. And instead, what I'm going to do is open the example new vehicle here. So this shows what the project looks like immediately after the import has begun. Let's see. So let me walk you through that.
Now, Warren, you mentioned it takes 3 minutes or so to import one of the reuse files. Now, you really mean it takes 3 minutes. You know, a lot of people say it only takes a few minutes, and you're going to use this several times during this webinar, but I just want to establish it for everybody listening that when we say a couple of minutes, we genuinely mean a couple of minutes, right?
That's correct, yeah.
Okay, go on.
It will vary a little bit with the size, but it's a quick import. It goes through and it does consistency checks and identifies all the interfaces and that kind of thing. So now you can see that after the import, we have quite a few of our folders have actually been filled up. And if I look at the component folder, for instance, we have our Flexi Fuel vehicle here. That's the one that I started out with. And then it imported the driver station here and its elements, and then the Flex Fuel engine as well and its elements. So along with these, we also imported a lot of other information. We imported, say, requirements. We only have one driver station requirement in here, and we have a number of engine requirements, like this Flex Fuel requirement. It imported tests. For instance, there's only a couple of verification methods, but here's one that measures the torque from that torque requirement. And if I click on this, we can see that this torque test validates the torque requirement that was imported as part of our reuse library. So it's really amazingly fast to create very complex systems models from a library of subsystems, components, or other elements. And what this does is it lets me build my model almost as fast as I can think. We call it operating at think speed. So let me show you now. We've imported these elements. We have to hook them up and connect them to the basic structure. So our structure for the Flex Fuel vehicle is still just a single element. Why is that? It's because I haven't yet connected anything up. But using our drawing pane now, I can start to do that. So by clicking on the component list over here, I'm going to just simply select the driver station, and I'm going to drag and drop it on top of the Flex Fuel vehicle system. And I'm going to say that the Flexi here is built from, or the driver station is built in to the Flex Fuel vehicle. And there it shows up. And I can expand it and see what other elements are also available underneath that. Now I also brought in the engine. So I'm going to grab the engine, and I'm going to do the exact same thing. I'm going to let me grab that engine like I said I would.
Grab that engine.
Grab that engine. Let's try that again. Grab the engine, and then I'm going to drag and drop it in to the system here. And just before I click on this, I want to point out that we do have other types of structures for our software brethren out there, and we do support the development of object-oriented structures as well. So now I very quickly developed a hierarchy, a physical hierarchy, an architecture that shows the entire Flex Fuel system. I'll zoom in a little bit here and you can see what some of these elements are. We have a nice drawing pane up here which I really like. Now there's also interfaces besides the component structure, the physical hierarchy, that need to be set up. And this engine control assembly here is one of the key ones. This engine control assembly needs to talk to the dashboard, and that's part of the driver station. So I'm going to go ahead and I'm going to hook up the interfaces to this dashboard. How do I do that? Well, I'm going to go to some other views of the system. This is a physical block diagram view, and we'll be talking more about views in a minute. But I'm going to take the connections and I'm going to start hooking them up. In fact, you know what? Before I do that, let me show you more specifically what it is I'm talking about. If I look at the interface block diagram for these parts of the system, there will be connectivity that's associated with these. So coming back to the driver station, let me go ahead and hook up these connections. Now we have the driver station engine subsystem interface, so I'm going to go ahead and hook that up. And when I do that, I see that the engine control system appears in blue because it is an external subsystem to the driver station. This is the driver station. We've now hooked up this link, an interface, to the engine control assembly, which is located externally in the engine subsystem. I'm going to similarly do the same thing with the interface block diagram. I'm going to grab the connection there, and I'm going to drag and drop it and hook it up as well. So what I'm showing here is that it's very, very easy to import elements from a reuse library or to create elements from scratch and then connect them up using the various styles of interface that the system requires. The last thing I'm going to show at this point, Jim, is I want to show how the traceability works for all of these different elements. So, for instance, if I go over to the requirements, I might select this flex fuel requirement here. This is the primary requirement on the system that says that we shall be able to operate with either gasoline or LNG, liquefied natural gas, which of course the U.S. has an amazing abundance of right now. And I can view this just by simply clicking on the hierarchy tab at the bottom of the window, and I can see the flex fuel requirement here at the top, and I can see that it is used to specify the fuel assembly component. But we also see that there's a risk associated with this, and this requirement can cause a risk associated with flex fuel availability. So let's take a look at that. I can open it up and see that the risk associated with this is that customers may not be able to get access to the liquefied natural gas fuel for their cars. It's an open risk. It's been mitigated, and we could have labeled it as unmitigated. But what is the mitigation? Well, what we've done is we've decided, as part of our company here, to provide liquefied natural gas refueling stations at every dealership. So we identified a risk. We linked that risk directly into the design. We can report on that at design reviews or to our customers or other stakeholders. And we've directly mitigated this risk. So I think, Jim, that, well, you know, let me show one other thing here. We can quickly build the systems models from this reusable library only because we are model-centric. But there are a few other ways that we can draw, create models and populate our model as well. One is just simply through the very traditional SysML diagram. Here we have a function that is the engine start function. Have you seen those cars, Jim, where I see ads for them where they have a start engine button on the dashboard? Yep. And you can press that? Yep. Well, we're going to do that, and we're going to do that in our system as well. So, so I've got a model here with a bunch of functions. I'm going to switch to the activity diagram, and we'll talk more about this. But here's a very straightforward activity diagram from SysML that models how that function would work. So, Jim, I think that, wow, I've been talking for quite a few minutes here.
Well, you've been doing a lot of work, and in just a few moments, you've gone from a clean sheet to a very well-populated beginning for this car. Now let me ask you a question, though. Some people say that by creating SysML diagrams like this one, they're creating a model and doing model-based systems engineering. Is this really true?
Well, SysML, it's the system modeling language, and it's a notational standard for drawings that's been published by the OMG, the Model Object Modeling Group, excuse me, which allows a pretty rich description of a system in these drawing notations. But you know, I mean, a set of drawings does not make a model. The way I think about it is I like to draw an analogy between model-centric and diagram-centric. I think about an architect for a house. He may draw a plan or elevation view, you know, from the top or front of the house, and put those drawings in a brochure and give it to buyers, but those sketches aren't the model. An actual physical model of the house, you know, it might be made of wood, it would sit on a table, you can walk around it. Carrying around a set of drawings really is not the same thing as having a model. Drawing diagrams or writing documents, that's diagram-centric, not model-centric. Now, the way I think about it is that we apply the exact same principle to model-based systems engineering. Creating a set of SysML diagrams is very useful, like this one here, but it's not enough. We're not trying to diagram the system. The end goal is to populate an underlying model from those diagrams. A model like this one in Genesys that can be shared and used by every member of the team.
Show me what you mean by that.
So I think, Jim, yeah, sure. So in fact, let's talk about views for a second. That's the second characteristic of MBSE. I think about that house, that model of the house. If we modeled the house in CAD, then the CAD software could auto-generate those plan and elevation and side views automatically. Each time we make a change to any element in that model, we could auto-generate the 3 views. And whatever that change was and whatever effect that change has would be reflected in each view. So in a diagrammatic-centric approach, making a change would require updating all 3 diagrams. In a model-centric approach, the model is created and the views are auto-generated from the model. Does this make sense to you, Jim?
Yeah, it does. It's interesting. I was just thinking about it while you were talking. 2,000 years ago, the architects building the pyramids were doing it using drawings on clay and paper. Papayas. Aren't people still doing that now in Visio? That we really, in some respects, haven't really progressed very much when we're just using these simple drawing diagrams. So tying this to systems engineering, the creation, say, of a SysML diagram, activity diagram.
Yeah. It's right. This diagram is actually, we're not just making the diagram, it's the act of populating the model.
Populating the model. Cool. All right.
So
now I understand. So Genesys will auto-generate a sequence diagram, right? And from the activity diagram comes.
Yeah, all of those. In fact, you're right. That's really what's so exciting. So MBSE is model-centric and it supports views. So if we have this activity diagram, and this is what I create, and I'll add to it in a minute. But the tool is populating the model when I create a diagram, and then it turns around and it auto generates, say, a sequence diagram from that model. So this is the exact same information coming from the repository, but it's being presented to us in a sequence diagram format. I can look at it as an n-squared diagram. Again, I created none of these models except for the activity diagram, but you can see that the interfaces show up there. Same with the hierarchy diagram, which we looked at earlier, and even a spider diagram, which shows kind of all the different elements and how they're connected. So I was talking to some friends of mine at a large defense company recently, and they were saying they do proposal work. They do a lot of systems design during proposals, and they were saying, "Gosh, we bring people in from all over the company to work on proposals, but they all are used to their own process. Not everyone understands how to read a sequence diagram. Those that do have it, and those that don't, can look at it from some other perspective." So let's see. I'm going to go ahead and modify this drawing a little bit and show you how what that effect is on these other views. So I'm going to go ahead and just actually, I'm sorry. Let me walk people through this a little bit. This represents that engine start that we mentioned earlier. So there's an engine start button that the user, the driver, would get in and press that engine start button. Then the dashboard, you can see we've allocated these. The dashboard would then use like an RFID to determine the location of that of the electronic key fob. And if it finds that the electronic key fob is present, then the car has authenticated the driver, and we'll go ahead and send a start engine command to the engine control system. And the engine control system will then manage the fuel, and determine what type of fuel they're going to use, and then start the fuel pumps over here, and then start the engine, and then the engine will run. So let's say that we want to continue to expand this model, and we're going to show how after the engine has started, we want to say initialize the rest of the electronics in the dashboard. So we'll call this initialize dash, and we would put a description here. And we could actually even allocate this if we want to the dashboard. And I can do that this way. I can also do it via drag and drop. But we'll go ahead and just add that in here. So now this has been allocated to the dashboard component. Now let's say there's a signal that gets sent in order to do this initialization. And let's say that this signal, we're going to create a new signal. We have some interfaces already. We'll create a new one, and we'll call this the init dash signal. So I add that in, and there it appears on my activity chart. Well, the act of creating this chart, this diagram, has also had Genesys working in the background, populating the underlying repository, and then generating the views, this information onto the other views. So if I look down here, I can see that this init dash and this behavior over here has now been allocated and put onto the sequence diagram. And the allocation I made has those functions appearing, those behaviors appearing in the proper swim lanes. Also, similarly on the n-squared chart, that information appears down here. We can see the init dash interface and so forth. So,
so really the model can auto-generate various views of the system, a sequence diagram, N2 chart, a hierarchy diagram. I mean, it can do everything.
I'm operating at my speed of thought. Maybe I'm not thinking quite fast enough as some others, but it's going pretty good for me. So, so that's exactly right. These views were generated by the model automatically when I created this behavior thread here.
So each change is shared by everyone on the team automatically, so that when Andy creates an activity diagram in Genesys, he's just not making a drawing. He's actually building the model through that diagram.
Yes, exactly. And Mike, say, can instantly see those changes on his computer in an n-squared chart, for example. Conversely, any changes that are made to any of these other auto-generated views, I can update the sequence diagram. And any of those changes that are made will, again, populate the model and round trip back to this activity diagram.
So it's just like a CAD system where the changes to the model of the house appear on an automatically generated elevation or plan views, right?
Yep. Genesys is like a CAD system for systems engineering. And at any given moment, the whole team can share one version of the truth.
But what about the work products? What's the benefit of all this for people?
Well, the SysML views are extraordinarily important, and they are a critical aspect of systems engineering. But they don't cover the whole story. They don't support trades. They don't support the test environment and so forth. Systems engineering is much broader than SysML. Like SysML, MBSE has to support requirements and parameters and behavior and architectures, but systems engineering, like I just said, is much broader than that. Systems engineering has to support verification and validation. It has to support risk analyses, those trade studies I mentioned, failure modes and effects, and it has to support programmatic reviews and change management and integration, and a lot. So in other words, I know.
Take a breath.
But that's true. Systems engineering is broader than SysML. And so if it doesn't support all of systems engineering, then we're not doing model-based systems engineering. So there are a lot of systems engineering views that are not covered in SysML, and those views are usually, like you said, publishable work products. Systems engineers need to produce specs. They need to produce system and software specs and ICDs and that kind of thing. So in Genesys, a system spec is really just another automated view, not a SysML view, but a Genesys view. And Genesys makes the generation of these work products really, really, really easy. Shall I show that off instead of talking so much?
Yeah, let's get into it again. Come on. Am I anxious or what?
It's good stuff. Okay, so down here, some people in the audience who maybe are familiar with Core would remember that there was a script generator up here, and a script runner. Now all the basic reports are built into the Explorer view, and we have canned reports. We have all of the DODAF 2.0 reports, and at any time you can right mouse click on one of these and you can run that report. Now, since I'm doing a car model, I have not included operational scenarios and the other elements necessary to support DODAF, so I won't be running one of those today, but they're all included. One of the things that's really cool about Genesys is that the system description document is one that can be used to generate an STD or a system design document anytime you want on any element of your system. So the STD, the system segment spec, is another one that's a really critical spec because it identifies the system requirements for the overall system. So let me see. Let me come over here. The STD report is one where you can get it output in a variety of different formats. All of them are. I would run this report. I'm not going to do that right now. Instead, because again, it doesn't take that long. It takes about a minute and a half. But I actually have run the STD report just before our webinar here, so I wanted to show you what information it shows up in it. So remember, this is a canned report that you can get out on your system just simply by populating it and building it the way I have been over this webinar. So this is a PDF version. I could have gotten it out in the Word format or any other format. I'll zoom in a little bit so you can see what this table of contents looks like. But you can see that this is a piece of documentation that can be given to any member of the design team to help them understand what it is that has to be built. It has the requirements and risks, use cases or functional behaviors. It has a data item dictionary, component description, and so forth. If I just scroll down, you'll see there's lots of figures in here, tables. All this information was pulled explicitly out of the model. If I change the model, I can click that run report again, and in a minute and a half I can have an update of, say, the flex fuel requirement. I can see if there are any key performance parameters associated with it, again from the model. I can see the requirements diagrams that match the SysML. Here's the find fob requirement associated with the dashboard. And I can go through and you can see page after page of these requirements. So let me scroll down so I can accelerate through this a little bit. Lots and lots of requirements, diagrams.
When you did this, it created a 55-page report in a minute and a half.
That's correct.
This is a piece of
art.
Correct. This is terrific.
It saves my fingerprints from rubbing off on the keyboard from all the typing I used to do. So here's the functional list here. This vehicle start, the behavior model. You can see the output, both a functional flow block diagram format and an activity diagram, SysML activity diagram, and it exported the sequence diagram as well. And you can see that that it's completely up to date with all the information that was in the model at the time that was run. So I'm going to fast forward again. Lots of I/O information here. You can see that there's these are names, but we have detailed descriptions of what the messages are. Here's a data item dictionary associated with few data items with fuel level and power and that kind of thing. And then all component description. This is the architecture section, and some of those are empty because there's no subordinate architecture below them. I'm just going to keep scrolling down here, and then we have an interface description. So it shows what the messages are, the interfaces are, and what they interface between. We also have a verification cross-reference matrix. I'm going to zoom in on this for everyone to see a little bit better. I have a couple of requirements here, and it identifies the method, analysis, inspection, demonstration, or test. You could also add measurement or calibration, that kind of thing, and also the verification level, whether something is going to be measured at the system level, like this driver authentication. It's a test that will be run at the system level, and then the torque test from the engine to measure its torque would be done at the subsystem level, and where it would be done at the supplier acceptance test event. So really, it's so easy to generate documentation. This is another good one. We did not build, no one watched me build a traceability matrix, but I suspect many of our listeners today have in fact had to do this kind of work in the past. Well, since GENESYS knows that you need to generate this, it took the content from the model and actually did that traceability for us. Acronym list, I could have imported an acronym list. I didn't choose to do that. Now, one last thing about the canned reports, and then I'm going to show you something even cooler, if you can believe that. I want to show you what happens when I run this report on a specific component. So I ran the exact same report, but I did it on the dashboard. And it has all the same types of information in it that you saw before. It has, like, for instance, the dashboard requirements, just those requirements allocated to the dashboard. It has the functional elements associated with the dashboard, the design. What this means is that if you're going to have, say, Lear, which is a big company in Detroit, that would maybe design and build a dashboard for you, you press the button, you take this dashboard spec, and you give it to them as a statement of work. You know that if they design to the spec, you'll have consistency with all the interfaces, all the functions that you need will be there, and so forth. So the canned reporting out of GENESYS is just phenomenal. But you know, that's not all. There is. So
there's more.
There is more. Let me take a little waddle.
Do you like reports or what? Are you?
Well, one has to communicate with people. Not everyone is going to have access to the model. Even though we do have the web server with GENESYS, and the review and comment people can get in and browse and comment, there's always going to be a need to be able to give someone an electronic copy of something that shows what their element of the system has to do. So yeah, you're right. I do like it because that's how I reduce defects in my systems. So yeah, so let me show you now a really neat new feature in GENESYS, and it's called the Report Designer. So you can see I've been playing around with it just because it's so fun. So I'm just
every time I look, you've got
report.
more in there.
Yeah. So the Report Designer is actually a part of the tool that lets engineers and managers create on-the-fly reports custom to their needs with exports to all the common formats, and there's no scripting whatsoever required to do this. It's really cool.
So if the project manager walks in and says to the systems engineer, we've got a sudden meeting in 15 minutes. I need you to pull up X report. And the engineer says, well, I don't have that, but I can pull it together, and I will walk in with 15 copies in 10 minutes. You're saying that's all possible?
That's completely possible, and I'm going to show people how it's done right now. So the way this works is that the Report Designer is actually querying the database, querying the underlying repository, and then pulling information out. So we have these, what is called bands. So I'm going to start telling the report designer how to query the repository, how to query Genesis. First, I want it to choose from among the projects and look at those. Then I want it to look at the data inside the projects, and it will query that. Then I want it to look at the folders inside the data inside the projects. That's these. Now we've got the report designer looking at the data in the folders. Okay, what kind of data do we want? Well, there's different types of data. We actually want it to look at the entities or the actual functions and components and requirements inside that. Okay, so once we've gotten down to that level, then we want to start looking at pulling information out of the folder. So I'm going to go ahead and drop in what's called a label. Again, it's all just drag and drop. And I'm going to tell it to go ahead and tie this label to the entities inside the folder. Okay? And I'm going to ask it to report on the name of that entity. Okay? So name. And I want to do a little bit of making it look nice. So I'm going to do something very simple here. I'm going to make it bold, but I can highlight it. I can do all sorts of different colored fonts and that kind of thing. Now the next thing I want is not just the name of the element, but I also would like to capture the description of that element. So again, I have to tell the label what it's looking for. So I will bind it to the entity again, and then I will add a description field. Now I could have combined these on the last chart, on the last entity representation, had multiple lines, but I decided when I was preparing for today not to do that because I wanted the other one bold and I wanted this one not bold. But you can see the richness that I can choose from here. I can get all sorts of information. I can get cost information. I can get contract number, and I can get who made changes to it, and the project unique identifiers, and just anything I want I can get out of this. Okay. Now, the last thing I want to do is on these folders, I really don't want to iterate through every folder. I just want to look at a set of folders. And in fact, I'm going to keep it simple here. I'm going to look at the functional folder. Okay. So I did no scripting. I did nothing that was more difficult than drag and drop. But here I go. I'm going to go ahead and preview this report. And you can see in just a moment, I now have a report of all of my functions. It shows the name of the function, determine fuel, and the description, which it pulled straight out of the model. Then it has a display engine started, engineer started, description, and so forth. Now all of these, you can see that it generated in moments. This can be exported to PDF. It can be exported to Word. We use the RTF format for that. HTML, native XLS or XLSX spreadsheets, and so forth. So what do you think of that, Jim?
I think that's really nice. And I can see how enthusiastic you are about it.
Well, I'll tell you what, it is cool, and I can do a little bit more as well. So I'm going to come down here, and I'm going to scroll down and grab this as well.
Here we go.
Yep. This is actually, I'll have to bind it again. So it pulls the information from the entity.
It's that easy.
And now when I rerun the report, let's take a look at what it does.
Voila.
Now it pulls whatever the behavior model is, the activity diagram for that function, straight out of the tool. And many of these are empty because it's just a demo, but if I come down to the bottom here, we'll see our big one. Isn't that something?
Yeah, this is neat. But time is a flying here, and we still got a couple subjects to cover. I'd like to get into the virtual system prototype that you mentioned earlier. Am I too early, or we about
No,
on
no,
time?
no.
So
You're absolutely right.
let's
I'm
let's
allowing myself to
let's look at
slip
this
behind here.
last characteristic of MBSE virtual prototypes. How does Genesis perform architectural trade studies and build a virtual prototype of your system?
Okay, yeah, that's a really good point. So let me talk about what virtual prototyping is real quickly. If we go back to that idea of the house, the model house made of wood, we can actually get a sense of the livability of the house right there from the model. For instance, if the kitchen door is going to intersect and hit the refrigerator door, we can see that from the model. Or if the second story deck is going to shadow the patio during summer or not, we can see that from the model. In fact, see, the model can act as a prototype of the house. So Genesis can do the same thing for a complex system with hundreds or even thousands of components. So how do we do this? Well, each function is implemented in a piece of hardware or a piece of software. I've shown that here by allocating these to the dashboard or engine control and so forth. And a lot of time and money is spent trying to determine the optimum architecture by companies out there. They buy hardware and build prototypes. They code software to flesh out system design. So now we have a simulator that allows us to virtually prototype our system right here inside of Genesis. So I'm going to go ahead and show that. The key thing here is that Genesis can execute the model using Monte Carlo techniques and using probabilistic inputs and durations over a range of operational parameters, just like the real world. And this allows our customers to know, not to guess, I'm going to click run here, but to know that the system will indeed work the first time around, it work as intended. So here what I've done is created a virtual prototype and run it of our system. So if we find failures in the virtual type, it just takes us a few minutes to fix them. So for instance, this one passed with flying colors. If you look at this, the way you read this, this is time going to the right. This is all the steps that occur in this model that I showed you earlier. So here's the user, the driver, pressing engine start. So we figure half a second for him to do that. Then here's 100 milliseconds for the dashboard to authenticate and find the fob, to locate that. If it is, then it sends that message to engine start. Engine start's been waiting. That's why this is yellow. It's enabled, but as soon as it receives that start engine message, it can start up, another 100 milliseconds, and so on and so forth through the entire system, including the function that I just added at the end to initialize the dash. Now, how long does it take for this entire sequence to operate? Well, if you look at the bottom down here, it took almost 2.4 seconds, 2,394 milliseconds. Let's go ahead. I'm going to hit reset and rerun this and see if we get a different number than 2394.
And
Now,
why would we get a different number? You mentioned Monte Carlo. Do you want to explain that?
yeah. In fact, we did get a different number, not much, a little bit. We got 2389. Yeah, what's happening here is that each of these functions has been spec'd to represent real-world behavior. None of our systems are probabilistic anymore. We never know when we send a message exactly when it will arrive. It's because we use networks and so forth for communication, when in the past, in the olden days, it wasn't like that. So here, we can actually use the probabilities of the bell-shaped curve, exponential, different probabilistic structures to model how long it will take for our various behaviors to perform. We can constrict bandwidth based upon the same 20 probabilities. By the way, if we want to specify this or anything in the tool using a script, we can do so using our Visual Basic API. In fact, if I wanted to, I could even populate this duration with content, say, pulled from an external finite element model using the Visual Basic API. But because of this, what that means is that every time we run this simulation, then we'll get a slightly different number. And we can run it over and over again, multiple times, and record the list of values that are output. And in this way, we can get a Monte Carlo simulation of the entire system. We can build virtual prototypes and save ourselves the money and the time of real prototypes. We can actually iterate and improve and test drive the system. We can build a new virtual prototype in minutes, not in days, and we can do it all at our desks and not at the bench. You know, there's some other aspects of the tool that I'd love to show, but we're kind of out of time. I'd like to exercise the API, but everyone knows what an API is, so that's probably something that people already understand.
Isn't this a wonderful time to be a systems engineer? Isn't this a great time to be alive and creating these products and having these kinds of tools at your fingertips? Well,
it really is. It's a lot of fun.
There's our last slide. And well, what we've seen here today is that Genesys implements the characteristics of MBSE. We saw that it's model-centric and supports auto-generation of views and documents, letting people work the way they want to work. But others can view the results in the format most comfortable to them. They can browse different formats like activity diagrams, functional flows, or sequence diagrams, or customize their own report using the report designer. That was really nice. In fact, Genesys saves tremendous money in document generation, and time is money. MBSE means that engineers and managers know their system design is complete and consistent.
Right.
What a good feeling. They can catch defects early on in analysis, preventing cost overruns and avoiding headaches and schedule slips and embarrassments down the road when they're integrating, testing, and deploying their systems. Boy, this is really nice for them.
Yeah, it is. And the virtual prototyping means lower material costs and wider use of prototyping to flesh out the design alternatives. It really does help people identify any defects and correct them early on when it's so much less expensive to fix and have much higher quality systems.
Well, we'd like to thank everybody for watching today and taking some time out of your busy day to look at the features of the Genesys MBSE tool. Warren, it's been great working with you again on this webinar.
Yeah, it has been great. Thanks a lot, Jim. It's been great working with you too.
And well, next week we're going to repeat this the 22nd, Wednesday, at 11 a.m. Eastern Standard Time, earlier in the day, so many of the people from other places in the world don't have to get up at midnight to watch this. And it's also going to be recorded and kept up on the website. But you and I have the pleasure of doing this again next week, which is going to be even better. So we'd like to make sure that everybody listening today, if you have somebody that wants to hear about this, they can either hear it in a recording or they can go ahead and hear it live next week. Right now we're going to open it to questions to Eva, and if as anybody types in questions, if anybody wants a private tour of Genesys with you and your team, just put in a little notation there, private tour requested, and Eva will take care of it, and Warren and I, or one of our senior account executives, will be happy to give you a nice in-depth tour of Genesys. Eva, are you there, and do we have any questions from people today?
We sure do, Jim. So joining us today for the Q&A session is our Director of Product Development, Lou Priolo. Lou has been working on Genesys since its inception, and there's no better person to give us some technical answers that we've all been waiting for. So ladies and gentlemen, don't take it easy on this guy. He really knows his stuff. Welcome, Lou. Thanks for joining us. So we've already received some really good questions, and we will get to them shortly. I encourage you to join the discussion right now and submit your questions via the Q&A function in the GoToWebinar window. All right, the first question we have is from Dan. He asks, how does Genesys support design reviews?
Mm-hmm. Can I handle this one? This is Warren. I think the thing that's really interesting about supporting design reviews with GENESYS is that it really reduces the amount of time and effort and money necessary to generate the work products, PowerPoint slides for the design reviews. We actually, with GENESYS, have customers that are actually doing their design reviews from the tool. So if they'll identify which views they want to show, whether it's say a sequence diagram or product structure, and then they'll literally move to those areas of the tool and talk about those aspects. You can also save any diagram off into a JPEG or other format, and you can actually use it to help you build those PowerPoint slides if you choose to do it that way. But the thing that's interesting is that one of the big time sinks that I've had in the past is that changes are made leading up to the design review, and then one has to update all those diagrams, and it's painful and difficult and often impossible to keep them all in sync. But with GENESYS, you can just simply publish, just like we showed in the demo, publish the work products literally hours before and have them available to the members of the team, and they're all complete and consistent and correct.
So there's no more of this as they're presenting, or they have documents, or they're actually presenting. The engineer doesn't have to say, well, please ignore this particular part of the diagram because it didn't get updated, but we'll get it done next time. That doesn't happen anymore.
That's right, and the engineer didn't have to spend hours creating the design in PowerPoint. So.
Okay, Eva, do we have any other questions there?
We do. Chris wants to know what type of organizations are currently using GENESYS.
Well, I'll handle this one too. I think that right now most of our organizations, our customers are using GENESYS, are those people that are most interested in plugging in their MBSE tool into other tools that they have on their campus. So they're the ones that are most interested in the SQL repository, in the Visual Basic API. They're using the tool for MBSE, and you can see that the tool is at version 2.0 is ready for that. But they don't necessarily need every single I dotted and T crossed on all the features that one might need going to the nth degree with a very detailed design. So I'd say that those are our current GENESYS customer kind of structure. Would you agree with that, Jim?
Yes. Yes, we do have worldwide users. We do have users all across the country and worldwide with varying degrees, and obviously most of them we can't mention their names, but that is the most common denominator. Do we have other questions, Eva?
I have one from Keith and also from Martin. Does GENESYS support integration with existing configuration management tools? What about simulation tools like MATLAB?
Who should field this one?
Lou?
I'll take that one.
Please.
We don't have any direct interfaces to any of the tools out of the box in GENESYS 2.0. That is something we will certainly be looking at providing in the future. We do have, as Warren discussed, the read-write.NET API. So it is relatively easy to interface with other tools that that can support .NET interface.
Mm-hmm. So if they understand the API to one of those tools, then either within their organization or with support from us, that could actually be crafted before we come out with it in perhaps later versions of GENESYS, it sounds like.
All right. I think this next one is best addressed by you, Jim. It's from Kelly. She asked, will core be phased out? Is it the intent for GENESYS to replace core altogether?
Well, core is not being phased out, and as most people know, core is still being sold vigorously across the country. We will have another release on core there. I've given away the store, so to speak. fairly shortly. And any users of Core can upgrade to Genesys anytime they want to, as long as they've got a current maintenance agreement. And we've had some people that are doing that. They may start with Core, and then they like what's happening with Genesys, so they upgrade. So many people are, as I say, still starting with Genesys and then upgrading later. So both products are being offered for the foreseeable future. They both have their own strengths, and we've got fans on both sides.
And if they do upgrade, is there any additional cost for them to do that?
No, there's no additional cost. As long as they've got...
Jim?
Yeah.
Well...
Yes, as long as their maintenance agreement is up to date, there is no additional cost. They can just move right on over, and we'll help them do that. It's no problem. It goes very, very smoothly. Right, Lou?
That is correct.
All right, I have another one from Kelly for you guys. Can you expect diagrams, or I'm sorry, can you export diagrams to Visio or other programs?
Currently, you can only export diagrams to image files, JPEGs, and things like that. You could use the .NET API to write a plugin to Visio or another tool. That would be relatively straightforward to do. And we have thought about doing that and may do that in the future.
Yeah, I think that I can see why people would be interested and curious about that. But that kind of obviates the model-based elements of MBSE when you start working on diagrams externally in a diagrammatic format in a tool like Visio or PowerPoint.
All right.
We're running a little late, Eva. Do we have any other questions?
We sure do. I'll pick about 2 more and we'll wrap it up. Does that sound good?
That sounds good. And then if anybody didn't get any of their questions answered, Warren and I will get back to them in the next few days, and we'll personally answer their questions.
All right. So Rick and Philip kind of asked the same thing. They want to know if you can show us all the reports available in Genesys.
Yeah. I can do that. So I think one of the key things is to recognize that you can now, with the report designer, create any report that you can imagine. Okay, that's really important. So there is an unlimited number of reports. If you can imagine it, you can create it. Out of the box, we have the system definition document, system description document. Those are the ones that I showed you here that you could use for your statements of work and so forth. We have a SSS, which is a system segment specification. This is the top level description document for your system. We also have all of the DODAF reports in version 2.0 of DODAF, and as you can see, there's something like 25 or more of them, 30 of them. There's a lot of them. All of these are implemented as well. So out of the box, that's the set of documentation that currently comes with GENESYS 2.0.
Thank you, Warren. And you had one other question, Eva?
All right, I have one more. This one I think is for Lou, and it's from Mohammed. Can existing core models with custom schemas be imported into Genesys?
Absolutely. Yeah, it's just a matter of running the import, and Genesys will bring in the core XML file.
Yeah, I'll add to that. In preparing for today, I did leverage some of my models from Core and brought them in, and I found it to be a really clean import. It was nice. You guys did a great job with that.
Well, that is great. I think we're at the end of our program. We've run a few minutes over. We were able to keep about 95% of the audience stayed in there. We really appreciate that. Please, we will get back to those people who we couldn't get their questions answered. And if anyone would like a private tour, don't hesitate to send wsmith@vitechcorporation.com an email, or Obermayer@vitechcorporation.com an email, or call us at the home office. Thank you very much. And don't hesitate to come to us, and we'll be happy to schedule that for you. And we hope that all of you had a good time. And if anybody wants to see this live, don't hesitate to come to the NCOSI IS show in June in Philadelphia. We'll have a great representation there, and we'd love to meet all of you. Come on by the booth, say hi, and we'll show you Core live, and we'll show you Genesys live in Philadelphia. Thank you very much, Eva and Bethany, our behind-the-scenes producer, and Lou.
Thank you.